here we go. Find dy over dx. Okay, so first, let's say y is equal to, so 3 to the power of cotangent of x plus secant of 2x cubed minus 3 times e to the power of pi plus 5. Okay, here's one. Number 2. Y is equal to the tangent power 4 of x2 e to the x and number 3. Y is equal to the big square root of x2 sine of 3x over x plus 2 to the power of 7. Okay, here are 3 derivatives. Sorry, you can't see the bottom. So here are 3 derivatives to evaluate. All right, so dy dx, or just y prime, whatever you want. I'll write dy dx for change. So the derivative of 3 cotan is, so stays 3 power of the cotangent times ln of 3 times the derivative of the cotan, which is negative cosecant squared x. That's for the first term. Second term, the derivative of secant is secant times tangent, so secant 2x3 times tangent of 2x3 times the derivative of 2x3, which is 6x2. That's it. And of course, the derivative of this is a constant, so this becomes 0. Questions? Good. Okay, let's do the second one. So dy dx, the derivative of tangent 4 is 4 times tangent cubed. Times the derivative of tangent, which is secant squared, times the derivative of the inside, which has a product rule. Okay, so the derivative of x2 is 2x e to the x plus x2 e to the x. That's my answer. Questions? All right, let's do the last one here. So here I suggest that we do a logarithmic differentiation. So the ln of y will be equal to, so if I do the ln of all this, I'll do a step. x2 sine 3x over x plus 2 power 7. And so ln y will be equal to, so 1/2 comes in front, right? Because everything's to the power of a half, times and ln of x2 plus ln of sine 3x minus ln of x plus 2 power 7. Okay, and that is equal to 1/2 times 2 ln x plus ln of sine 3x minus 7 ln x plus 2. Okay, so this is ln of y. Okay, I'm just going to continue up here. Okay, so I'll continue up here. And now I'm going to derive. So 1 over y times y prime equals 2 1/2 times 2 over x plus, so 1 over sine 3x times the derivative of sine 3x, which is cos 3x, times the derivative of 3x, which is 3, and then minus 7 over x plus 2. Okay, and that's it. Now I could just isolate y prime and I'm done. So y prime is 1/2 times y, which is square root of x2 sine 3x over x plus 2 power 7 times, and now this will be 2 over x plus 3. So cos over sine is the cotangent of 3x minus 7 over x plus 2. That's my answer. Okay, so we did 1, 2, 3. Let's go number 4. So let's say e power xy minus 3x2 minus 3y2 equals to 2. Okay, so again, find dy dx or y prime. And then one more here, number 5. Y is equal to, so 2x minus 3 over cos x, all this to the power of x. Okay, so the first one, we have to do it implicitly. So the derivative of e power xy is just e power xy times the derivative of the exponent, which is a product rule. Okay, so 1 times y plus x times y prime minus the derivative of 3x2 is 6x minus this will be 6y times y prime, and this is 0. Okay, and that's it. Now I just need to isolate y prime. So y prime times, so x e to the xy minus 6y equals, whatever, it doesn't have a y prime, I stand on the right, so it's 6x minus y e to the xy. And I could find the y prime. 6x minus y e to the xy over x e to the xy minus 6y. There you go. Okay, number 5, we do it using implicit logarithmic differentiation by putting a ln on each side. So ln y is equal to ln of 2x minus 3 over cos x power x, so the x comes in front. And that is equal to x times so ln of 2x minus 3 minus ln of cos x. And I'm going to derive both sides now. So 1 over y times y prime equals, and now don't forget here I have a product rule, x times all this. So it's 1 times all of this plus x times the derivative of this bracket. which will be, so 1 over 2x minus 3 times 2 minus 1 over cos x times negative sign. Oops, I'll move up a bit, sorry. And that's it. Y prime is y times, so y is this, times this whole thing. So ln of 2x minus 3 minus ln of cos x, so ln of 2x minus 3 over cos x. So I'm recombining it, plus x times 2 over 2x minus 3 minus is plus, sine over cos is tangent. There we go. That's my answer. Any questions?
Sir?
Yeah.
Could you repeat why is it minus sine of x over cos of x?
Why is this minus sign?
Yeah, and the minus before, yeah.
Okay, so the minus here comes from this minus.
Okay.
Okay, and then the derivative of ln of cos, so ln 1 over cos, and chain rule times the derivative of cos, and the derivative of cos is minus sign.
Oh, okay. Okay, thank you.
Okay, let's do another one. So consider the curve. Okay, so all these are exam questions defined by xy2 minus x3y is equal to 6. Okay, so that's a curve. So first question, show that dy dx is equal to 3x to y minus y2 over 2xy minus x cubed. First question. Second question, find all points on the curve whose x coordinate is 1, and write an equation of the tangent line at each of these points. Okay, so here it is.
I have a question.
Yep.
How is it possible that there's multiple points with the same x coordinate?
Because it's not a function.
Oh, it's not a function?
No, nobody says it's a function. I say it's a curve. The curve could be a circle, could be an ellipse. I don't know what that is.
Okay.
Okay. It's good that you be careful with this. Good. Okay. Okay, so the first one we do implicitly. So the derivative of xy2 is 1 times y2 plus x times 2y y prime. Okay, that's a product rule. Minus the derivative of x3y, again, product rule, so 3x2y plus x3y prime equals to 0. Okay, so again, I'm going to isolate y prime. So y prime times 2xy minus x cubed. Okay, so this term and this term equal, this goes on the other side, so 3x to y minus y2. And so y prime or dy dx is 3x to y minus y2 over 2xy minus x cubed. Okay, so that proves that that's the derivative. B, find all points of the curve where the x coordinate is 1. So we just plug in x is 1 in the function, in the relation, sorry, it's not a function. So 1 y2 minus 1 cubed y equals 6. Okay, I just replace x by 1. So that means that y2 minus y minus 6 equals 0, y minus 3 y plus 2 equals 0, and so y is 3 or y is negative 2. And so my 2 points will be 0.13 and the other one will be 1 minus 2. Okay, let me try to fit everything on this little side here. So at 1, 3, what is the slope? So I just need to replace 1 and 3 in here. And I'm going to get the y prime. So 3 times 1 squared times 3 minus 3 squared over 2 times 1 times 3 minus 1 cubed. And so I get 9, I get 0. I get 0. Okay, and so the equation here, y is equal to 0x plus b, and so it will be just 3. Y equals to 3 is the equation here. Okay, and then do the same thing with 1, negative 2. So y prime is 3 times 1 squared times y, which is negative 2, minus negative 2 squared over 2 times 1 times negative 2 minus 1 cubed. And so I get minus 6 minus 4 is minus 10. Minus 10 over minus 4 minus 1 is minus 5. So minus 10 over minus 5 is 2. And so you could find the equation. We have the slope, we have a point. So y equals 2x. And so I need to find, I think it will be minus 4.
Sir?
Yeah.
I have a question.
Yeah.
When we were solving for the tangent line in the denominator, isn't it minus 1? So
Where?
in the denominator to your left, yeah. In the denominator, that is 6 minus 1, right?
Yeah.
Doesn't that change? Isn't the slope going to be minus 18 over 5?
It's not 18 on top.
How much
It's
is
3 times 1 times 3 is 9. 9 minus 9 is 0.
Oh yeah, sorry. Okay, I made a mistake.
Okay, no problem. Okay, so we found two equations, y equals 3 or y equals 2x minus 4.
But isn't the top of the second like where you found 2? Isn't it minus 2 over I forget what the bottom one is.
Here?
Yeah.
3 times minus 2 is minus 6, right?
Mhm.
Minus negative 2 squared is 4.
Mhm.
So minus 6 minus 4 is minus 10 here on top.
But isn't it minus 6 like plus 4 because it's okay, never mind.
Okay, no problem. Okay, any other questions before we move on to the next one? Okay, let's go. Next question. Okay, let's move up a bit in the course. So we did today derivatives, implicit differentiation, logarithmic differentiation. That's what we did so far, I think. Let's do one of the theorems. Okay, so example. So consider the function so f of x is x cubed minus 7x minus 10. Okay, first question. Use the intermediate value theorem. Okay, IVT, remember, is the intermediate value theorem to show that f has a zero on the interval so let's say -1, 4. First question. Second question, find the number in -1, 4 that satisfies the mean value theorem. And C, use Rolle's theorem to show that there is a number C in -1, 3 such that f prime of C is equal to 0. Okay, so this is a question where you have to just know how to apply these three theorems. So A, so the intermediate value theorem, let's find what f of -1 is. Let's find what f of 4 is. F of -1 is -1 cubed, -7 times -1 minus 10, and that is equal to -1 plus 7 is +6, -4 is -10 is -4. And f of 4 4 cubed minus 7 times 4 minus 10. And that's what? 64 minus 28. And minus 10, so it's 26. Okay, so basically, four minus 1 y x. So at minus 1, it's minus 4, and at 4, it's 26. So definitely the function, as you see, it crosses the x-axis at one point, so there's a 0. Okay? So we have to write now, since f is continuous on minus 1, 4, and f of minus 1 is negative, and f of 4 is positive, then by the intermediate value theorem, there exists, so this sentence is important, you have to write this, okay? There exists a value C in interval minus 1, 4, such that f of C equals to 0. Okay, that's the intermediate value theorem. B. Okay, so the mean value theorem, if you remember, we're looking for f prime of C is equal to f of B minus f of A over B minus A. Okay, so what is the derivative? It's 3x2 minus 7 has to equal to, so f of 4, which is 26, minus f of minus 1, which is minus 4, over b minus a, which is 4 minus minus 1, which is equal to, so 26, 30 over 5 is 6. Okay, so this means that's 3x2 minus 7 equals 6. x2 is 13 over 3. And so x has to be plus or minus the square root of 13 over 3. And of course, negative 13 over 3 square root is...
Sir,
Yes?
can you lower the page, please?
Oh, thank you, sorry. 13 over 3 square root. Yeah, so it's plus or minus 2.08. Okay, so the only value that fits into minus 1, 4 is x is 2.08. Okay, last one. I'm going to try to fit again Rolle's theorem here. Number C. F of minus 1 is, we just found it as negative 4. And f of 3 if you plug in 3 in your function, I get 27 minus 21 is 6, minus 10 is -4.
So where does the 3 come from?
In the question,
Oh, okay, okay.
-3, okay? So just 1 second here, if I'm to express what just happened here. So -1, -4, and 426. And the function is like this. There is a value where the slope is exactly the same, okay? This value here was 2.08. Okay, and now for C, since f of -1 is equal to f of 3, then it for sure is a value where the slope is 0, okay? So since, I'm gonna write this, since f of -1 equals f of 3, and f is differentiable, right? The derivative exists. On -1, 3, then for sure there exists a value C in -1, 3, such that, sorry, it's a bit small, f prime of C equals 0. Let's find that value quickly. The derivative is 3x2 minus 7 is equal to 0. And so x is equal to plus or minus square root of 7/3. Okay, so it's just going to be 1.53 about.
But technically, did we need to write the value in the answer?
So what
The value of x, or did we just need to say that there was one?
oh, you just need to say that there was one.
Okay, cool.
Exactly. In the question, it just says show that there is one.